Hey y'all. Oh, let me get my face in this. All right. Hey y'all. I just realized I never posted the video for the first integral unit 3 assignment, and I might not even have recorded it. So I can't find it. I'm recording another one. Here we are. Hello. I'm sorry this is late. Okay, so the two main things we're looking at in this assignment were the notation for the definite integral and how it relates to the area, and then also kind of what's the difference between a definite integral and an indefinite integral. So let's go through it. The graphical representation of area, if I have like a function and I want to find the area underneath it from a certain point to a certain other point, right? So if I want to find what's the area underneath this curve from 1 to 3, the way I'm going to write this in calculus class is I'm going to go from 1 to 3, to the leftmost to the rightmost. Then I'm going to write the function, and then I'm going to end with a dx. So anytime we'd see this, we can think of it as the area underneath this function. And anytime we see this area underneath the function, we could think of it as a definite integral, right? This makes more sense to us because people are generally visually and as physical object. And then this is easier to work with because we know how to manipulate algebra to make it say stuff we want it to say. Let's do another example. Same function, but if we're looking at a different part of the area, right? If we're looking at, say, this part, the integral notation would still be integral of negative x squared plus 3x plus 4 dx. But now, instead of looking at the part that's between 1 and 3, we care about the part that's between 0 and 2. So our upper and lower bounds now become 0 and 2. I'm going to name these parts really fast, just for funsies. I think we've done this in other notes, but never too often. The lower bound is called the lower bound. Very creative, right? Upper bound is this top number that tells you where we should stop to the right. The function is called the integrand, but honestly, we're just going to call it the function a lot. And then this is called the differential, and we're just thinking of it as a full stop, like a period at the end of our integral sentence. It tells you that we're integrating. It tells you that we're using x as the variable, but honestly, for single variable calculus, we're basically using it as a full stop. And then down here, these were all definite integrals, and the things we've been working on in class so far have been definite integrals. The notation is, let's make it red, from a to b, the integral of f of x from a to b, you're finding the area of, the area between f of x and the x-axis from x equals a to x equals b. And this is going to be a number, right? The answer to a definite integral is always going to be a number. On the flip side, the indefinite integral is just integral of f of x dx. There are no numbers. There's no upper or lower bound involved. And what you're finding is the area equation. Right? So your answer here is going to be an equation. It's not going to be just a straight number, or it's usually not going to be a straight number. And this is more of finding things in general. And then so far we've learned how to calculate the number for definite integral using a calculator. We're about to use the indefinite integral to calculate the definite integral. That's something we'll do next week. But that's the lowdown of the first assignment. What we're doing is we're given a bunch of these, and we need to match it to these. Then we're given a bunch of these, and we need to match it to the picture. And then we need to say we can tell the difference between this notation and this notation, naming this one is definite and this one is indefinite. All right, y'all. I'll see you on Tuesday.